Let us construct a frequency distribution. Welcome to STATScreen. When the data include a large number of observations, it is convenient to group the values into mutually exclusive classes and show the number of observations occurring in each class in tabular form. This tabular form is what we know as the frequency distribution. A sample is shown below. A simple frequency distribution essentially has two columns. One is for your class intervals, or the range of values, and you have your class frequencies, which corresponds to the number of observations falling in each class interval. The class intervals, again, refers to the classes or divisions of observations. In each class interval, you can determine the class limits. Let's use this class interval here. For this class interval, 21 is what is considered as your lower limit, while 25 is your upper limit. Now, aside from class limits per class interval, you can also determine the class size or class width per class interval. But the class size and class width is constant all throughout class intervals. So using the same class interval 21 to 25, we can just simply count the number of observations belonging in each class interval. For this case, 21, 22, 23, 24, and 25. There are 5 observations. That would mean our class size, our class width, is 5. This is very important as we construct our frequency distribution later. The class frequency, on the other hand, signifies the number of observations which fall on a specific class interval. Later, we are going to determine the class frequency for each class interval. But for this example, let's say the class interval 21 to 25, the class frequency is 12. Or in short, there are 12 observations falling in this interval. Before we proceed in constructing a sample frequency distribution, do you know that for our latest 100 subscribers, 12 belonging in the age 18 to 22, 75 belonging to 23 to 27, and 13 of age 28 to 32. 0 subscriber from age 13 to 17. If you would like to, you could be the next. You could add up and become the new frequency for each interval. As for that, please click the subscribe button below. Now, we are to construct a frequency distribution. In constructing a frequency distribution, we could start with this step. We are to compute the range. Let us consider these given values. In computing for the range, we are going to subtract the smallest value of the observation from the largest value. For this given set of data, 64 is our largest value, while if you're going to look at it closer, you will have 16 as your smallest value. With this, our range can be computed as 64 minus 16, which will give you a result of 48. This is for step 1. Let's record that and move to step 2. The step 2 is by computing the number of possible class intervals. We can determine this by using this formula intended for k, which corresponds to the number of class intervals. 1 plus 3.332 logarithm of n. N stands for the total number of observations in this given set of data. If we're going to count the number of observations here, our n is 40. And we are going to input that in our formula. And by using any calculator, you would get a result of 6.34. But since we are determining the number of class intervals, which are whole number in nature, let us try to round it up to 7. Instead of rounding it down, let's round it up to 7. Again, let's take a note of this as we proceed to step number 3. For step number 3, we are going to use the results for step 1 and step 2, because in computing the class size of width, you already know earlier that it corresponds to the number of observations that is part of your class interval, or corresponds to the items that should be placed in a class interval. That's I here. We can compute that by dividing your range R by K, which is the number of class intervals. So we have 48 over 7, which will give us a result of 6.86. Same as step 2, for K, we rounded it up. Let us also round this up to 7. This is also important because, again, I corresponds to class width. It could help us construct a better frequency distribution. For the class width is constant all throughout the class intervals. Let's record this. Let's proceed to step 4. Step 4 is now constructing a sample table. Our frequency distribution table, or the simplest form of a frequency distribution, usually consists of 2 columns, the class intervals and frequency. Before we go to frequency, let us determine the correct class intervals. We could start constructing our class intervals using the smallest value of 16. This should be our starting point. Then, using the class width of 7, we would know that the upper limit of this first class interval would be a range involving 7 possible entries. So 16 to 22, that would mean our upper limit for the first class interval is 22. To get the next class intervals, we will just add the class width for each of the lower limit and upper limit. That would mean for our next class interval, the lower limit is 16 plus 7, that's 23. As for the upper limit, 22 plus 7, that's 29. Doing it so on and so forth, these are our 7 class intervals. Now that we have the class intervals, let's proceed to the frequency. Let's start the tally. We need to count the number of observations in our set of data values, which will fall on each of the class interval. You can just simply crash out or cancel out all of those items. So let's start with the first class interval, 16 to 22. You will have 21 and 16 and no more. So you will have a frequency of 2. Next, the class interval of 23 to 29, we have 24, 28, 25, and 29, a total of 4 observations. For 30 to 36, so on and so forth, you will have 9. For 37 to 43, you could also have 9. Just refer to the table data of set of data here. 44 to 50, you will have 7. 51 to 57, you will have 5. And 58 to 64, you will have 4. You would know that the number of frequencies are correct if they will sum up to the total number of observations, n equals 40. This is how we construct our simple frequency distribution in 5 steps. Now, I would like you to try this. I'd like you to give the correct distribution of the frequencies for all class intervals. So you could answer 2, 1, 7, 9, 8, 0, so on and so forth, that can be formed using the given values below. In order for you to do that, you need to follow the steps that will reach you to step 5, the tallying of frequencies. And if you're done, I would like you to share your answers as a comment to this video. This is all about constructing a simple frequency distribution. This has been StatScreen.